In this video, I'm going to show you an update I did in the target flow algorithm to avoid having oscillations in the pressure, especially when the grind was too coarse by mistake. The old algorithm, the one that I was using so far, was trying to react based on the changes in the weight. But now what I did was trying to predict the pack resistance based on the pre-infusion and some other data that I tried to model in the algorithm. So I'm going to show you one example of the old algorithm with the oscillation I mentioned, and after that what happens when I'm using the predictive algorithm, the feed-forward one. This is one case of the oscillation I was mentioning. As you see, we start with a pre-infusion of 6.9 bar. Then at 7.2 seconds we detect the first drop. The pressure drops to 0 bar. And after some seconds, the flow target algorithm picks up and tries to match the target flow we had set. At that point it was 1.9 grams per second, I believe. And if you see, what happens is that the pressure immediately jumps to 9 bar, which is our cap. The flow starts increasing, it goes beyond the target flow rate. This takes some time, of course. Then the algorithm tries to compensate and reduces the pressure a lot, crashing to 0 bar, but still water is going through our pack because of the coarse grind. Then with some delay, the flow rate drops below our target, so the algorithm again increases the pressure aggressively, and you see this kind of oscillation, which is not optimal, of course. We don't want to go to the maximum pressure and then crash it to 0 and then again take it up to the maximum. This happens in a feedback loop when there is a delay between the action and the reaction. So the overshoot is pretty clear, and I'll show you now how the similar espresso pool looks with the updated feed-forward algorithm. Right, this is another shot with a feed-forward algorithm. Again, we have the pre-infusion at 6.9 bar. First drop is detected before 6 seconds. For me, this is an indicator that the pack resistance is not great based on my personal tests. And then we enter the waiting phase. After some seconds, again, we have the flow rate phase. I updated the graph so now you can see the target flow rate with a yellow line. And as you see, the algorithm does not increase the pressure aggressively. It increases it more slowly, and it never reaches the 9 bar cap like before. Now it reaches up to 6 and then gradually corrects it to match the target flow rate. We have way better results here. The target flow rate was achieved comparatively easily without any oscillations. So this algorithm works perfectly fine for coarse grinds. Of course, it will not affect anything negatively in case we have a perfect grind that gives a lot more pack integrity. I'll remove the pressure bar so you can see better what's happening. You see in the main stage the target flow and the actual scale flow pretty close to each other without any oscillations. Before closing this video, I'd like to show you that I kept the old algorithm in case someone wants to do A/B testing and see which algorithm works better for them. So if you go to a stage that is flow controlled, you'll see here the new toggle switch. The resistance feed forward is the new algorithm that doesn't have oscillations. And if you disable it, you can see the legacy auto-tune algorithm I was using with a basic feedback loop. So I'm looking forward to your testing and giving me your results and how the new algorithm worked for you.